And this is going to be a shorty. This is part 3 of this week's lecture, and we're continuing to talk about hypothesis testing. Okay, so some other examples with other statistical tests. All right, state the null and alternative. I want you to state the null and alternative hypotheses here. Okay, so on the first one, think about this in your brain. Compare the average number of pints of beer consumed in one evening between guys and girls. And the second one is, what is the relationship between political orientation, Democrats versus Republicans, and opinions on abortion issues, agree or disagree, etc.? What is the null hypothesis, and what is the alternative hypothesis? And the third one is the relationship between doing your readings for the stats course and finishing your master's on time. All right, so figure out what those are. All right, how do you know when to reject the null hypothesis? Okay, this is important to know. We set the criteria or region for acceptance of the null hypothesis. This criteria or level is known as, this is important alert, this is known as the alpha level, and we're using the Greek letter alpha, all right? And right here, the alpha level, or level of significance. So when we say, is this test statistically significant? The alpha level is what we're talking about. So in research, we commonly find that we use a 5% chance or 0.05 or 5% level of significance. We want our alpha to be at 5%, or even better if it's at 1%. What does that mean? That means that we have here a 5% chance of being wrong and a 95% chance of being right. All right, so if the test is statistically significant by showing that I have an alpha level of 0.05, that means that I only have a 5% chance of being wrong, and at 95% is where we want to be. This means that I have a 99% chance of being correct and a 1% chance of being wrong. Wow, that's pretty good, isn't it? So how do you know when to reject the null hypothesis? This is, let me go back. This is where the concept of statistical significance is important. The alpha level indicates the likelihood that a result is due to chance. Significant. Okay, so common levels of significance, as I said before, are 0.05 right here. This means that the finding has a 95% chance of being true. True here means that the finding would be replicated in the entire population. Okay? In other words, there is less than 5% chance that the findings can be attributed to chance. I'm just having a sip of tea here. Excuse me. There's a difference between the probability value, p-value, and the alpha. All right? So p-value, the significance level, is the point at which we would consider a result to be very unlikely. Generally, what do we say? The 0.05 level of significance is used. A p-value, on the other hand, is the value based on the empirical data. All right. Also, SPSS is going to give you both these numbers. If you want to compute them by hand, go ahead. It indicates the probability of your result being true. You want a p-value, all right, less than 0.05. Okay, so here's the uncertainty and errors in hypothesis testing. The alpha level determines the probability of type 1 error. What is that? We'll explain. In general, alphas of levels 0.05 and 0.01 are considered reasonably good. Okay, and here's the actual situation. So here's my rejection, here's my retention of the null hypothesis. Okay, so I have type 1 error if no effect, and the and the type 1 error is there, and the effect exists, and that means that the null hypothesis is false. Okay, so I could either have type 1 or type 2 error, and here's the possible here's the possible outcome. So if I fail to reject the null hypothesis, all right, and there is no effect, that, in other words, it's true, then I have a type 1 error. If the effect exists and the null hypothesis is false, then the decision was correct. Okay, so that's about it. We talked about null hypotheses and alternative hypotheses this week. We talked about alpha levels and p-values. Okay, so those are things to remember and things to be aware of. And we talked lastly about this type 1 and type 2 error. Okay, so remember, a type 1 error happens when you reject the null hypothesis when it's true. So the probability of type 1 error is the level of significance of the test of hypothesis, and we call it the alpha level. And type 2 error occurs when you reject the alternative hypothesis. In other words, we fail to reject the null hypothesis when the alternative hypothesis is true. All right, and the probability of type 2 error is denoted by beta. Okay, and we cannot evaluate the probability of type 2 error when the alternative hypothesis is has a mean greater than 180. But don't worry about that right now. So again, type 1 error occurs when you reject the null hypothesis, when the null hypothesis is true, and it is the alpha level. And the type 2 error occurs when you reject the alternative hypothesis when the alternative hypothesis is true. So you have type 1 and type 2 errors. Pretty simple. Okay, so listen, we'll see you next week. Now that this screen recorder is working again, I'm going to try to do a homework review from last week for you. And if you have any questions, as usual, scream.